Hello everyone. Today we learned in class how to do joint hypothesis testing. These are hypotheses that involve more than one coefficient. For example, we want to know whether racial dummies are jointly statistically significant. In this podcast, I want to show you how we could do this in R. I open up R. I already typed up my code so that you don't have to wait for me to type it in. And first I point R to the folder where I store all my data. I load in the CPS file. The CPS has the information on salary, education, age, and so on. And it has 4 dummies that indicate the individual's race. Here, individuals are categorized in one of 4 different race categories. I first estimate my unrestricted model. I'm going to call it model U. And that model includes salary as the dependent variable, education, black, Asian, and other as independent variables. If I run this regression, I look at the summary, I get my coefficients. Now what I need is a sum of squared residuals from this model. The regression output doesn't directly give me sum of squared residuals. It gives me things that are related to it, but not the sum of squared residuals. So I have to calculate it using a function residuals. Okay, so if I actually typed in residuals of model U and I execute that line, it plots or prints all the residuals from that model. That's not exactly what I want. What I need is a sum of all these numbers squared. And I can do that using a function sum, and I feed it the residuals from model U squared. So if I run this and then I print the sum of squared residuals, it's the number that we saw earlier in class today. That's 1.2498 times 10 to 14th power. So that's the first thing I need. I need sum of squared residuals from the unrestricted model. I also need the sum of squared residuals from the restricted model. The restricted model involves only salary and education, because my null hypothesis says that the coefficients on these 3 racial dummies are equal to 0. So when I plug that hypothesis in, my restricted model just has salary and education. So let's run that model. Summarize it. This is the familiar regression result that we saw before. Let's calculate the sum of squared residuals from that model. So that's going to be the model R for restricted. Let's print the sum of squared residuals, and here is the number. It's 1.2557 and so on times 10 to 14th power. Now, of course, I could take my 2 sums of squared residuals and plug them into this complicated formula, plug it into a calculator and calculate my F statistic. Today, I don't feel like punching it into a calculator, so I'm going to ask R to actually calculate my F statistics. So I'm going to type in a formula that has the sum of squared residuals restricted minus sum of squared residuals unrestricted divided by 3, which is the number of restrictions in the null hypothesis, and that whole thing is divided by the sum of squared residuals unrestricted divided by the number of observations minus the number of slope coefficients in the unrestricted model. I can calculate that, I can print that, and it gives me 100. So of course what I typed in here is really just the formula that we see on our handout. The value we got is 100. In class, I believe we got 150, but that's because we rounded a lot. When we don't round, we actually get 100. Still, that's way bigger than the critical value of 2.6, and we know that if the actual F statistic is bigger than the critical value, we reject the null. So we reject the null big time that race doesn't matter. Right? That is rejected big time. Race does matter, unfortunately, but that's it for today.